In example number 9, we're solving polynomial equations. A new bakery offers decorated sheet cakes for children's birthday parties and other special occasions. The bakery wants the volume of a small cake to be 351 cubic inches. The cake is in the shape of a rectangular solid. They want the length of the cake to be 4 inches longer than the width of the cake, and the height of the cake to be 1/3 of the width. What should the dimensions of the cake pan be? Now we have to begin by writing an equation for the volume of the cake. The volume of the rectangular solid is given by the formula V, which is equal to the length times the width times the height. Now we were given that the length must be 4 inches longer than the width, so we can express the length of the cake as L, which is equal to W plus 4. We were given that the height of the cake is 1/3 of the width, so we can express the height of the cake as H, which is equal to 1/3 W. And then the width would just be W. So if we write the volume of the cake in terms of the width of the cake, V is going to equal the length, which is W plus 4, times the width, which is W, times the height, which is 1/3 W. And if we multiply it all together, we get V, which is equal to 1/3 W cubed plus 4/3 W squared. Now we're going to have to solve for W by plugging in the volume of the cake at the beginning of the problem. So the volume was 350 cubic inches. So we're going to place V to be 351. So we have 351, which is equal to 1/3 W cubed plus 4/3 W squared. So we want to make sure that we don't have any fractions. So we're going to multiply both sides of the equation by the LCD, and the LCD is a value of 3. So if we multiply the entire equation by 3, 3 times 351 is 1053. 3 times 1/3 just gives you W cubed, plus 3 times 4/3 W squared is 4W squared. And now what we're going to do is now we're going to set this entire equation equal to 0 by subtracting 1053 from both sides. Now, Descartes' rule of signs tells us there is one positive solution because we have a sign change from here to here. The rational zero theorem tells us that the possible rational zeros are plus or minus 1, plus or minus 3, plus or minus 9, plus or minus 13, plus or minus 27, plus or minus 39, plus or minus 81, plus or minus 117, plus or minus 351, and plus or minus 1053. Now we can use synthetic division to test these possible zeros. Only positive numbers make sense as dimensions for a cake, so we need not test any negative values. So let's begin by testing values that make the most sense as dimensions for a small sheet cake. So we're going to use synthetic division to check x is equal to 1. If we plug 1 into the function, you can see here that we get a remainder of negative 1048. So therefore it's not a zero of the function. Now we'll check 3. When we put in 3, we can see that we also get a remainder of negative 990. So that is not a zero of the function. If we plug in 9, we can see that we get a 0 of the remainder. So synthetic division gives us a remainder of 0, so 9 is a solution to the equation. And we can use the relationships between the width and the other dimensions to determine the length and the height of the sheet cake pan. So to find the length, we're going to take the width, which was 9, and add 4, which gives us 13, so the length is 13. To find the height, it's going to equal 1/3 of the width, so 1/3 of 9 is equal to 3. So the sheet cake pan should have dimensions 13 inches by 9 inches by 3 inches.